So here what I have is I have some expired Juvederm Ultra XC, and over here I have Aquaphor. And the reason I put some Aquaphor on this tray is just so we can get a sense of what the filler material may, good comparison, because all of us know what Vaseline or Aquaphor feels like. So I'm gonna go ahead and I'm gonna actually inject some of this. And the first thing that you could see is how cohesive the product is. If you zoom in a little bit more, you'll see that almost a huge blob is created before the product even leaves the needle of the syringe. Go ahead, zoom in a little bit more if you can. Yeah, I'll keep it there. So you could see, I mean, this product is pretty cohesive, pretty thick. A lot of this product has to be really removed from the syringe, and then a huge blob is created before that product is evacuated from the syringe. And you can see it's a pretty cohesive product. It sticks relatively well to each other. This blob has a tendency to not move. So once it's injected and it stays on the tray, notice the blob stays put pretty much where it is. It doesn't liquefy or get more wet, so to speak. Its consistency does not change. Its consistency is pretty much uniform throughout the entire part of the delivery. And even if you look very closely, each time I press the syringe, we're getting almost exactly the same kind of consistency of the product. Now, this is true of all fillers today because fillers are made extremely well. They pass through different sieves, sieve after strainer, after strainer, after strainer. So they're very, very well made. But you can get a sense of what this product is able to do just by virtue of seeing it sort of pile on each other like an iceberg. And the product does not move. Once it's injected, for the most part, over here, we see that, it pretty much stays where it is. Its rheological properties do not change at all once the filler is exposed to air or once the filler is exposed to other parts of itself. We still have a little bit more to go. So I'll go ahead and you can see how you create that blob, and then the blob is released on top of everything else. And then we'll go ahead and we'll look a little bit closely at the different characteristics. So let's keep it zoomed there. So if we look at the filler, we could see it's got a very jelly-like consistency. Notice that when I move it, it resists its movement and it comes right back to where it was before. So even if I move it a significant amount, the filler stays put. So this is a very thick filler. It's a very thick filler with a lot of resistance. It does not significantly move. Now, of course, in a face with the actions of muscles and the SMAS and different things pulling it in all different directions, we can see that the filler will likely move, or at least move a little bit. But you can see how thick the product is. It's a very, very thick product. It's very resistant to motion. It does not move. It's really got the consistency of Jell-O. It's almost, you can penetrate it with the needle, but it pretty much stays the same. If we zoom out a little bit, we can compare that to, let's say, for example, the consistency of an ointment. Where the consistency of an ointment is the exact opposite. The ointment basically moves wherever we want it to move. The ointment will take the shape of whatever we want it to. The ointment does not stay put. The ointment itself can be completely moved over and reshaped. Whereas the filler is very resistant to motion. It's very, very resistant to motion. Now go ahead, if we zoom in on the filler a little bit more, we can see just how resistant this is to different motion. When we move it, the filler goes right back to where it is. If we stab at it, the filler goes right back to where it is. So it's a very cohesive in general when you compare it to other ointments, other types of material that we are familiar with. The filler is very, very resistant. Now you can imagine how devastating this is if me physically trying to move this with my Q-tip over here and the filler is very resistant. You can imagine if this is placed in an artery and blood is moving against the filler, how that blood can easily back up and not be able to penetrate that vessel because of how resistant the filler is to any kind of movement, any kind of physical movement. So again, you can imagine if blood is flowing through a vessel, and this is a vessel, and this is how resistant the filler is, there's no way blood is going to get through that vessel. And that's the important property of fillers. Fillers are extremely resistant to physical activity, to physical movement, to physical transition. You could see this filler is barely moving. Now what we'll do is we'll go ahead and we'll take a look a little bit at the consistency of the product. And I'm going to just grab a little bit of it in my hand. And you could see the consistency of this product. You'll get a sense. Now notice when I picked it up, the entire thing came in one pickup. That shows you how consistent this product is. You could never do that with Vaseline. So again, you put it back down, it's got the consistency of slime. You pick it back up, it comes all together as a blob. This is a good thing and a bad thing. You know, in certain areas where you place it, you want it to be like this. In certain areas, you don't want it to be like that. And of course, you never want this to be like this when you're, you know, inadvertently in a blood vessel, because you have this entire blob that is resistant to motion. Now I have my fingers pointed in the direction of gravity, and you can see the filler will not fall. The filler will stay consistent, will stick to each other. It's extremely cohesive. This is why the filler can be dangerous if it's inadvertently injected into a blood vessel. It resists almost every kind of physical transition you may want to perform on it. See? Even now, it's completely stuck together. We're letting gravity take its course to see if gravity will bring the filler down, but how cohesive it is, it resists even gravity. So again, it's a very, very thick product. You could see just its properties here. And sometimes it helps just to see the properties of fillers to understand kind of what you're dealing with. If you don't know what you're injecting, you've never felt the product in your hands and your fingers, then you really don't have an understanding of what the product is capable of, both good and bad. This feels like slime in between my fingers, and you can see just how consistent it is and also how cohesive the product is. It's a very cohesive product. And it's a product that resists a lot of change. Now, if you compare that to something like Vaseline, you could see the Vaseline is just very easily manipulated. It doesn't stick. It has no cohesiveness, right? So the reason I compare it to Vaseline or Aquaphor is because, not because fillers are like Vaseline or Aquaphor, but because Vaseline or Aquaphor is a very thick ointment that we are very familiar with because we've used it for a lot of different reasons on our skin. We think of it as very thick. Imagine when that goes on top of your skin, how thick it feels, how clogged it feels, right? If you put it on the skin long enough, you'll even get milia. But then I want to compare that to something that's even thicker and more cohesive than that, which is the filler. I made this video because a lot of people requested this video after my last video explaining just how much filler is in one syringe. So I wanted to take a good look at the real logical properties of fillers. There's resistance, its elasticity, its resistance to gravity, what it feels like, what it looks like, all of these different tactile properties of the filler so we can understand both its good and its bad. So to just review, here what we have is Juvederm Ultra XC. It's a pretty thick, cohesive filler in the Allergan family. And one of the important things to realize is that, you know, all fillers are not created equal. Fillers can be very, very thick, very cohesive. They can resist a lot of motion, as we showed over here. That's good and bad. It's good when you want to place it in an area and you don't want it to move. It's bad if it's inadvertently placed in a blood vessel and now you have this devastating blob, this iceberg that just will not melt.